Okay, so welcome back. So now what we're going to do is we're going to start talking about the signs of trigonometric functions. Okay, so this is where we're going to start looking at the reference angle, and we're going to use the fact that the reference angle or the terminal side will end up being in one of the four quadrants of the Cartesian plane. And if it ends up in one of those quadrants, then it's going to affect the sign of the trigonometric function, right? So before we had our triangle and we had our reference triangle the same, but now we're going to look at what happens if the triangle ends up in a different quadrant, okay? So for example, if we look at the first quadrant, right, which is what we're normally looking at, for the previous examples where we're introducing trig functions, we were looking at this generic right triangle. And we have x, y, and r. And so since it was in the first quadrant, x and y were both positive. We know r, the radius, is always assumed to be positive. And so, so all of the identities that we were looking at was based off of this. Now, the thing is that since r is always going to be positive, right, then what we look at is y and x. Now, look at the Cartesian plane. We know that this is the positive x-axis, this is the negative x-axis, this is the positive y-axis, and the negative y-axis. So there are negative and positive values of x and y depending on where the terminal side of the angle goes to. So if you're in the first quadrant, then x and y are both positive, right? If you end up in the second quadrant, then x becomes negative and y stays positive. And then if you go to the third quadrant, then what do you have? You have both of them negative. Both x and y become negative. And then if you end up in the fourth quadrant, then x is positive and y is negative. Okay? And so we can use this for when we are calculating the trigonometric functions, because depending on which quadrant they are, we know by the different ratios what the sign is going to be. And so we can fill in this table by just referencing what we just talked about. Okay, so remember, so over here, just to kind of fill it in over here, and I'm talking about x and y, okay? So not talking about r. Remember, r is always positive, so don't get confused by this. So I'm going to say for xy, and I'm just going to put xy in here, r is always positive. So in this quadrant, it's always going to be positive, positive, right? So if I look at points in that quadrant, x and y are both going to be positive. If I go over here, I'm going to have negative and positive. So x is negative, y is positive. And then down here in the third quadrant, it's going to be negative, negative. And in the fourth quadrant, it's going to be what? Positive, negative. Okay? So now based on these facts, guess what? I can fill in this table, and I know that sine, okay, so r is always positive. So when is y positive? Y is positive in the first and second quadrant. So that means this is going to be a plus, this is going to be a plus. And y is negative in the third and fourth quadrant. So it's going to be negative, negative for sine. Now what about cosine? Well, cosine is x over r. Well, r is always positive, so we have to look at the sine of x. Well, x is positive in the first and fourth quadrant. So that's going to be plus, and then it's negative in the other two. Tangent. Now tangent is the ratio of x and y. So again, it's going to depend on what quadrant we're in. So x and y, so again, in the first quadrant, they're both positive. So this is going to be positive. Positive divided by positive, positive. In the second quadrant, x becomes negative. So positive divided by negative, negative. In the third quadrant, they're both negative. So negative divided by negative is positive again. And then in the fourth quadrant, it's negative again. Now, cosecant of theta is the reciprocal of sine. So again, cosecant is going to follow the same pattern as sine. So it's going to be plus, plus, minus, minus, and then secant is going to follow the same pattern as cosine because it's just the reciprocal of sine. So it's going to be plus, minus, minus, plus. And then cotangent is the reciprocal of tangent. So again, it's going to follow the same pattern as tangent. So it's going to be plus, minus, plus, minus. And so those are the patterns, if you will, for the different trig functions. And so again, use this to your advantage and make sure you understand this. And this is going to help you make sure you get the correct answer. Talk to you soon.